In this video, we'll continue our discussion of triple integrals by working another problem. This is going to be another setup. So set up a triple integral for the volume of the solid bounded above. Alright, so we should probably write, if it's bounded above, this is our top. And below by that, so this is the bottom. Alright, so that will handle my z. We can actually deal with that. Let's go ahead and write down our z's here. The bottom is going to be 2x squared plus 3y squared. The top for z is going to be 9 minus y squared. All right. And then we'll figure out our y's and our x's. Right. We have two surfaces. They're going to intersect at some point, and that is the region that we need to project down onto the xy axis. I have the region already drawn here because that ellipse was extremely difficult to get to look like a decent ellipse at all. So I got as close as I could and left it. Let me show you how you get there. We're going to just set our z's equal. I want to find where they intersect, and we're going to project that down. Alright, so I got 2x squared plus 3y squared. I set the two z's equal. Now I'm going to try to solve these things. Okay, I add yx over. I got 2x squared plus 4y squared. We need to get this equal to 1, so I'm going to divide everything by 9. So I got 2x squared over 9 plus 4y squared over 9. Now, that doesn't normally look like the ellipse we deal with. We like x squared over some number. So here's a little trick here. We can just flip that fraction. This just becomes 9 over 2. And then this y squared here, I just flip that one and it becomes 9 over 4. So if we're looking at our axes, I take the square root of those. I get 3 over the square root of 2 in the x direction. So you can see that on my graph there. Oh, couldn't get that out. And then the b is the square root of that, which is 3 over 2, and that's in the y direction. So that's why we have our two values there. In the y direction, we have 3/2 in our axes. For our axis, major axis, it's double that. And then 3 over square root of 2 will be in our x direction. So there's our ellipse. Let me shrink this down because I want to... Actually, I can't even reach it there, so we'll leave it. Actually, I can do this. All right, so that's how we get to that. Now, that doesn't help us with our y's, except for we can use this statement right here. Okay, I'm going to solve for y here. So if I do that, I got 4y squared equals 9 minus 2x squared. What I'm trying to do is bound y. I'm going to divide everything by 4, so I get y squared equals 9 over 4 minus 1 over 2 x squared. Okay, and then we're going to take the square root. So, and be careful, you can't take the square root of each one. It's going to be y equals plus or minus the square root, and this isn't pretty, and it's okay. 9 over 4 minus 1/2 x squared. Please do not put 3 over 2 and then the other thing in parentheses. We can't split square roots across plus or minus. So this tells me what y is bounded between. It's bounded between 9 over 4 minus 1/2 x squared and negative of that same thing. And then x, if I look at my graph over there, it's bounded between that and the positive of that same thing. All right, let's set up our integral. We have everything we need there now. X is caught between negative 3 over radical 2. And positive of that same thing. I found when I write my integrals like this, it feels a little neater, and when I'm looking back, I can really tell what's going on. So y is negative the square root, because I'm not shoving them in there, 9/4 minus 1/2 x squared. And then I got y equals the square root of 9 over 4 minus 1/2 x squared. And then my bounds for z is going to be, the bottom one is 2x squared plus 3y squared. And the top one is 9 minus y squared. If I'm finding volume, I want my integrand to be 1. And then I just got to make sure I respect the order of the bounds. Z is on the inside, y is in the middle, x is there. All right, the answer here is definitely not nice and pretty. If you work this integral out, we get an answer of v equals 81 over 4 square roots of 2 pi. Again, on the assessment, I may just have you set up and stop and not go down. More than likely, that's actually what a lot of problems will be like for this exam. Will be a whole lot of setup. I will have you work a couple triple, double integrals for me, but I'm not going to have you work every single problem down to an answer. I'm just going to have you set it up and leave it. I have multiple reasons for this. One, length of the test. If I had you work out every integral, I think I could give you 5 problems instead of 10 to 15. Another thing is when you get to your field, if you're doing anything like this at this point, I would use a computer. Even to get this answer, I plugged it into a computer to get that answer. That's just kind of how the real world works. We need to be able to do integration, because if we lose that, then eventually nobody will know how to integrate, and we're using programs we don't understand. So again, setup is important. Setup is the difficult part. That's what I'm mainly going to be looking for through a lot of these triple integrals and some of the sections after this one.